Let's look at some more problems involving partial derivatives. Suppose y is a function of x1 and x2, which is, say, x1 times x2 plus 2 times another function of x1 and x2, which is x1 plus x1 squared times x2. How do we now find all of the partial derivatives of y? We're going to have two, the partial derivative of y with respect to x1 and the partial derivative of y with respect to x2. So let's see, let's start with the partial derivative of y with respect to x1, and now we use the product rule. So remember the product rule is the first times the derivative of the second plus the second times the derivative of the first. So here's how we're going to do it. The partial of y with respect to x1, rewrite the first, times the derivative of the second with respect to x1. What's the derivative of this second function with respect to x1? Term by term, it's going to be 1 plus 2x1 x2 plus the second, rewrite the second, x1 plus x1 squared x2 times the partial derivative of the first with respect to x1, which is just x2. Now we have to find the partial of y with respect to our next independent variable, which is x2. And again, we have to use the product rule to do it. So we rewrite the first as the first times the partial derivative of the second, now with respect to x2. So it's going to be 0 plus the coefficient of x2, which is just x1 squared. So it's the first times the partial of the second with respect to x2, plus the second, just rewrite the second, times the partial derivative of the first with respect to x2, which is just x1, and there's your answer. Let me give another example of partial derivatives using the quotient rule. Suppose y is again a function of x1 and x2, and in this case it's equal to x1 times x2 minus 7 divided by x1 plus x2. How do we find the partial of y with respect to x1 and the partial of y with respect to x2? We have to use the quotient rule. So let's first of all get the partial of y with respect to x1, and here's how we do it using that quotient rule. We take the denominator, rewrite the denominator, times the partial derivative of the numerator with respect to x1, which is just x2, minus the numerator, just rewrite the numerator, times the partial derivative of the denominator with respect to x1, which is just 1, all over the denominator squared. And finally, let's get the partial derivative of y with respect to x2, and again we have to use the quotient rule to get this. It's equal to the denominator times the partial derivative of the numerator with respect to x2, which is just x1, minus the numerator, just rewrite the numerator, times the partial derivative of the denominator with respect to x2, which is just 1, all over the denominator squared.